differentiation of log x, that is 1 upon x, integration of x square, that is x cube by 3, and we need to integrate the multiplication of these two with respect to x, right? So here after all I will get x cube into log x by 3 minus this 3 is constant, so I will put 1 upon 3 here, and x cube upon x, that is x square into dx. And now very easily I can integrate this function, so the solution is this one is equal to x cube log x by 3 minus 1 by 3 x cube by 3 plus c, because integration of x square, that is x cube by 3. So finally the answer is x cube log x by 3 minus x cube by 9 plus c. So this is the evaluation of integration x square into log x into dx. So by using integration by parts we can solve this example. I want to remind you one more thing, that we have said that in this integration by parts formula there is two functions of x, u and v. So we will select a one as a u, second one as a v. ક્યારેક એવું બની શકે કે માનો કે તમને ઇન્ટિગ્રેશનની અંદર બે નહીં પણ ખાલી એક જ ફંક્શન આપેલું હોય, માનો કે log x ફોર એક્ઝામ્પલ, તો બીજું ફંક્શન ન હોય તો જ્યારે આપણે ખાલી log x નું ઇન્ટિગ્રેશન કરવું હોય તો આપણે u તરીકે log x અને v તરીકે કંઈ ન હોય તો આપણે 1 સિલેક્ટ કરીને પણ ઇન્ટિગ્રેશન બાય પાર્ટ્સનો યુઝ કરી અને એનું ઇન્ટિગ્રેશન મેળવી શકીએ. તો અત્યારે તો આપણે ક્વેશ્ચન પેપર સોલ્વ કરીએ છીએ. જેવું આ ક્વેશ્ચન નંબર 5B ફિનિશ થશે એટલે હું પાછો આ વસ્તુ તમને રિમાઇન્ડ કરાવીશ અને આપણે એક એવો એક્ઝામ્પલ સોલ્વ કરશું કે જેની અંદર એક જ ફંક્શન હોય અને આપણે ઇન્ટિગ્રેશન બાય પાર્ટ્સનો યુઝ કરી શકીએ. સો this is for the reminder of you. So now let us move to the example number 2 of question number 5B. Okay, the question number 5B example is the second example is evaluate integration x upon x plus 1 x upon x plus 1 into dx. Here just we need to use the simple logic, that is in the denominator here there is x plus 1. So if I arrange x plus 1 in the numerator, then we can easily simplify this expression and then easily integrate this example. So I will start with x upon x plus 1 dx. This one is equal to, I can write x plus 1 minus 1, right? So plus 1 minus 1 cancel, that is x upon x plus 1, right? I am grouping these two, x plus 1 minus 1 into dx. So હવે this one is equal to x plus 1 upon x plus 1, that is 1 into dx. X plus 1 upon x plus 1, that is equal to 1 into dx minus 1 upon x plus 1 into dx. So integration of 1, that is equal to x, integration of 1, that is x, minus integration of 1 upon x plus 1, that is log mod x plus 1 and the constant c. So this is very easy example of integration. This is just one logic that we need to create x plus 1 in the numerator to simplify the expression. So we have arranged here x plus 1, so I have put minus 1. So x plus 1 upon x plus 1, that is equal to 1 into dx minus 1 upon x plus 1 into dx. So integration of 1, that is x, minus integration of 1 upon x plus 1, that is log x plus 1, then the constant for the integration. So this is the final answer, x minus log x plus 1 plus c. Okay, so this is the second example. Okay, now the last example of question number 5b, which is the question is find the area. Question is find the area of the region bounded by the curve y is equal to x square and the line y is equal to x plus 2. The question is find the area of the region bounded by the curve, that is parabola, y is equal to x square and the line y is equal to x plus 2. Okay, so here let us find the area for the region bounded by y is equal to x square and y is equal to x plus 2. So let us first find the intersecting points of y is equal to x square and y is equal to x plus 2. Okay, so if we want to find the intersecting point of y is equal to x square and y is equal to 2, then we will get here y is equal to x square and here y is equal to x plus 2. So we will get directly x square, that is equal to x plus 2, because y is equal to x square and y is equal to x plus 2, that means x square is equal to x plus 2. And by simplifying this one, I will get this one implies x square minus x plus 2, minus 2 is equal to 0. And by factorizing this one, I will get x plus 1 x minus 2 is equal to 0. Okay, x plus 1 x minus 2 is equal to 0. That means here x is equal to minus 1 or x is equal to 2. We have two possibilities for x, that is minus 1 and 2. If x is equal to minus 1, then y is equal to x square, so minus 1 square, that is equal to 1. And if x is equal to 2, then y is equal to 2 square, that is equal to 4. So the intersecting points are, here. I tell a, first point a, that is equal to minus 1 and 1. So first point is minus 1 1, and second intersecting point b is equal to 2 4, right? This is the second intersecting point. And as we know, here y is equal to x square, that is a parabola, and y is equal to x plus 2, that is the straight line. So if I draw here the diagram of y is equal to x square and y is equal to x plus 2, and we have already get the intersecting point, that is minus 1 1 and 2 4. So if I draw here the figure, here that is x, here is y, and the parabola, this is y is equal to x square, that is symmetric about the y axis, and we have 2 points, that is -1 1 and 2 4 here. So this parabola is something like in this way, right? This is the parabola y is equal to x square. For example, something here, there is a point -1 1, this is a, -1 1, this is point n. If there is, here is 2, then in this point b 2 4 are intersecting point, and y is equal to x plus 2, that is line. So that is line which is passing through these points, okay. So this is the line, y is equal to x plus 2. So we need to find the area of the region enclosed by y is equal to x square and the line y is equal to x plus 2. So this is the region of which we need to find the area. Here this is point, I want to write down here, this is -1 1, this is 2 4. So now we have the formula for the integration of the region between two curves, two function f1x and f2x, and that is, as we know, area A, that is equal to integration a to b f1x minus f2x into dx, or I can say y1 minus y2 into dx. We have two curves, y1 is equal to y, that is equal to x plus 2, and the second curve, that is y is equal to x square. So here, and the limit of x, that is from -1 here and 2 here. So limit of x, that is from -1 to 2, f1x, let f1x is equal to x plus 2. So here this is x plus 2 minus f2x, that is equal to x square, that is y is equal to x square, that is second function, this one is the first function, right, into dx. So we can easily integrate this integration. So integration of x, that is x square by 2, integration of 2, that is 2x minus x cube by 3, and note that this is the definite integration, so there is not any constant c here. So here we need to put the limit from -1 to 2. So this one is equal to, this one is equal to, if I put 2 here, first the upper limit, then this 2 square, that is 4 by 2. So 2 here, 2 into 2, that is 4 minus 2 cube, that is 8 by 3, this is the upper limit, minus lower limit, that is -1 square, that is +1, so that is 1 by 2, 2 into -1, that is -2, and -1 cube, that is -1, and minus minus plus, so this is plus 1 by 3. Okay, so by putting the limit and by simplifying these terms, I will get the answer is equal to 9 by 2. So we can easily get answer from this one by taking LCM. So this one is equal to 9 by 2 square unit. Okay, એમાં આપણને એવો પણ ડાઉટ જઈ શકે કે જો મેં f1x ઇઝ ઇક્વલ ટુ એક્સ સ્ક્વેર અને f2x ઇઝ ઇક્વલ ટુ એક્સ પ્લસ 2 લીધું હોત તો આપણને આન્સર છે એ કદાચ માઇનસમાં મળી શક્યો હોત. પણ આપને ખબર છે કે એરિયા છે એ નેગેટિવ હોઈ શકે નહીં, તો આપણે એરિયા ઓલવેઝ માનાંકમાં લઈએ છીએ ઇન મોડ. સો ક્યારેક એવું બને કે જો તમે ફંક્શન્સ f1xની જગ્યાએ અહીંયા f2x અને અહીંયા f1x લીધેલું હોય તો એમાં કોઈ પ્રોબ્લેમની વાત નથી, કેમ કે એરિયા છે ઇઝ ઓલવેઝ પોઝિટિવ. સો વી વિલ કીપ ઇટ ઇન મોડ. સો ક્યારેક જો એવું બને તો તમે મોડ્યુલસ લઈ અને એને પણ તમે ફાઇનલ આન્સર લખી શકો. સો ધીસ ઇઝ ધ એરિયા ઓફ ધ region enclosed by these two curves y is equal to x square and the line y is equal to x plus 2. So in this way, this is the end of the solution of GTU question paper June 2013 for advanced mathematics group 2. So this is the end of solution of this paper. We have some time, so let us try to solve some typical examples of integration. I told you that I will remind you later that then if in the integration there is any function when there is like this one, I have remind you that when we want to integrate any function by the method of integration by parts, then we will use the method integration u into v dx is equal to u integration v into dx minus integration du by dx into integration v dx and the integration of this bracket, right? મેં તમને ત્યારે પણ કીધેલું હતું કે ક્યારેક એવું બની શકે કે તમારી પાસે u અને v બે ફંક્શન ન હોય પણ માત્ર એક જ ફંક્શન હોય. ફોર એક્ઝામ્પલ only one function log x, then how to integrate this function using integration by parts, because we have not any formula for the integration of log x directly. So let us look at one example that of evaluation of integration of log x dx only, right? So here we have only one function. So if we want to use this formula, then we need to take v is equal to 1, right? So for this formula, let u is equal to log x and let v is equal to 1, because there is nothing in the multiplication of log x, that is there is 1 in the multiplication of log x. So we can take v is equal to 1, and using this formula I will get integration of log x